In the previous lesson, we talked about addition, subtraction, and multiplication. So to round this out, in this lesson, we'll talk about division. So in example 1, we're going to divide the polynomial 20x to the fourth minus 10x squared plus 5x by 5x. I think the simplest way to visualize this would be to just set up one fraction where you have 20x to the fourth minus 10x squared plus 5x, but this whole thing is being divided by 5x. The reason this is nice is you can split this up into 3 separate fractions and then just cancel any common terms. So that is, this is 20x to the fourth over a 5x minus 10x squared over 5x plus 5x over 5x. If you think about it this way, now we can just cancel any common terms and write what is left over. So for the very first fraction, 5 goes into 20 a total of 4 times. And also, there's an x to the first and an x to the fourth. I know that's going to reduce to an x to the third, because you can cancel one of the x's. What's left over is 4x cubed. We'll just do this for every single remaining term, and we're done. So we have 5 goes into 10 twice, and here you have an x to the first divided into an x squared. This is going to leave you with an x to the first left over. So this whole thing reduces to 2x to the first, which I won't write. And for the very last fraction, 5 goes into 5 once, x cancels with x. In fact, the only thing left over is going to be plus 1. So this is what it looks like to divide two polynomials. It turned out to be relatively easy just because what we were dividing by was one single term, 5x. And this is a decent approach for it. Also, if you work through a few of these, you really even don't need this step over here once you see how it works. You could just say, oh, I got 5x, I'll cancel it into 20x to the fourth, and then I'll just repeat this process for the remaining terms in the numerator, and this is the final answer, and it is simplified. For example 2, again, we're just dividing polynomials, but the thing that's tough about this one is we're dividing by 2x plus 1, so we can't quite use what we did in the previous example. What we're going to have to do is use the division algorithm. So maybe just as a quick recap, just off to the side, if I said 5 divided into, 117, there's an algorithm for this that you can, do by hand so you don't have to use a calculator. And the algorithm that we use here is exactly the same that we'll use on polynomials. So maybe just to, recap, what we do is we take the 5, I note that it can't go into the 1, so we just kind of move over to the 11 and ask, how close to 11 can we get? I know it would be multiplying by 2, so I'll put a 2 above where the 11 is, multiply the two numbers, and then subtract what we have. And then I bring down the 7, and I have this new question of, well, how many times does 5 go into 17? And that would be a total of 3 times. That's the closest you can get, because it gives you 15. You take the difference, and you're left with 2, and the process is over. 5 goes into 117 23 times, but there's just a little bit left over. There's 2 remaining. 5 doesn't evenly go into it. You could actually say, 5 is not a factor. And the reason is because the remainder was 2, it wasn't 0. But just to leave that over here, I'm going to write down 2x plus 1 divided into 6x squared minus 7x minus 5. And I want to use the algorithm that we use for whole numbers on polynomials. The way this works is you look at your 6x squared and you want to completely cancel it. That's kind of like looking at the 11 and saying, all right, I want to cancel as much of that as possible. So I put something above the 11 that multiplied to the 5 to get me as close to 11 as we could. So, okay, using that logic, I have a 6x squared, and I'm multiplying 2x plus 1 to get as close to it as possible. To do that, I'm going to multiply 2x by 3x. The reason is 2x times 3x is 6x squared. And I'm going to write that above the x's. So that is, I put my 3x up here, and I multiply to this whole thing. So I'm going to do a little work off to the side. I'm multiplying 3x to 2x plus 1. It gets distributed to both terms, but we do get 6x squared, but there's this 3x that is left over. That whole thing I'm going to write here, 6x squared plus 3x. So far I'm just mimicking what we did over here. I looked at the 11, I could get to 10 by multiplying by 2, that's the closest that I could go without going over, and then I subtract whatever I put here. So that's what we haven't done. I have to subtract this 6x squared plus 3x. And this is where you have to be a little bit careful. When you subtract, as we've seen before, a polynomial, both of the terms become negative in this case. So we have 6x squared minus 6x squared is 0. I'm not even going to write it. Then I look at my negative 7x, and I subtract 3x, and that gives me negative 10x. And I bring down the 5. And we're almost done. All we have to do is multiply 2x plus 1 by something to get a negative 10x. And I know what's going to work. It's going to be negative 5. So I'm going to place that right here. Again, off to the side, why this works is if I multiply negative 5 to 2x plus 1 and distribute it in, we get negative 10x minus 5. And I'll place that right here. Now, I'm subtracting this, but that actually kind of works out perfectly in this example. You have negative 10x plus 10x, which is 0. Then we have negative 5 minus a minus, so it's going to be negative 5 plus 5. Actually, that's also 0. So at the very bottom, I'll just put 0. That's the remainder. That actually means that 2x plus 1 is a factor of 6x squared minus 7x minus 5. Said another way, if you took 2x plus 1 and you multiplied it to 3x minus 5, the result would be 6x squared minus 7x minus 5. So that's what division really does. It takes something and it breaks it apart. So we started with 6x squared minus 7x minus 5, and when we divided it, it broke it into these two pieces. So division is the inverse of multiplication. We started here. When we divided, it gave us this. Well, if you multiply these together, it would take you back to this. So here's the division algorithm just applied to polynomials. And for the last example, really just repeating what we did in the previous example, but maybe just with some different numbers. So I have 3x minus 1, and that's being divided into 15x cubed minus 11x squared minus 19x plus 7. So, the values, there's just another term. There's an x cubed instead of stopping at an x squared, but that shouldn't cause a problem. This should really work the exact same way. In that, I look to this portion, and I want to cancel 15x cubed. So I'm really asking myself, what do I multiply 3x by for that to happen? Well, it would have to be a 5, and then an x squared, because that would give me 15x cubed. I'm going to place that above the x squareds, so to fill that in, my choice is 5x squared. And the reason is when I multiply it to 3x minus 1, it gives me 15x cubed. I also get minus 5x squared, but I can deal with that later. Now what I'm doing is just subtracting the things I just came up with. And it should work out very nicely. 15x cubed minus 15x cubed is 0. Great. Now I have negative 11x squared, but it's going to be plus 5. So I'm left with a negative 6x squared. I bring down the negative 19x, and I just repeat this process until I get to my last spot. Okay, let's see. I want to get a negative 6x squared, and I'm thinking about what I multiply this by. So let's see, that's going to be It's got to be negative. In fact, it should be -2 to give me the -6, and an x, because x times x is x squared. So that's what I'll place up here, -2x, because I get -6x squared plus 2x. Okay, now I'm subtracting this stuff, and I'm left with the -6x squareds. Oh, those are going to cancel because I'm subtracting them. But then I have -19x minus 2x is -21x, and I'll bring down the 7. Great. At my last possible place value, so I have a -21x. Oh, I think this is going to work out nicely. I'll have, if I multiply this by -7, it's going to cancel this. So I'll put -7 here. I'll get -21x plus 7. Those are identical, which is great, because if you take the difference, you're just left with a remainder of 0. And here it is. We divided 3x minus 1 into the polynomial, and what came out was 5x squared minus 2x minus 7, and that is it.